Hey everybody, you want to have your magnetism homework number 1 in the mark. That's the one where you read chapter 1, or really skimmed chapter 1, section 2 about the Earth magnet. Make sure you have recorded tonight's homework, which is going into another section. It's also there in the classroom. So this lesson you're going to be looking at how do magnetic poles interact. But before that, we're going to look at some of the stuff we did yesterday. So objectives today, we want to define what a magnetic pole is, describe interactions between like and unlike poles. You probably know what that's going to be. You're going to discuss the homework and solve a hands-on problem. And why we do this, basic understandings of magnetism to solve a new problem. Again, just giving you chances to use your hands and utilize your knowledge. So first you're going to discuss, in these groups of 3 or 4 that you're in now, discuss section 1-2. You'll share your results of the activity yesterday, which was to try to make your own compass. And then you'll get back with your seat partners and do magnetism activity 2. How do magnetic poles interact? So what you should do is have your homework in front of you. Make sure you're on that side of it. And so you're looking at the box that says Earth as a magnet. The first part was explain how the Earth is like a magnet. So pause the video and then have everyone go around and share what they have. Once everyone's shared, come back and we'll talk about what we have. Okay, everyone should have shared in your group. So the Earth has an immense magnetic field. It has a north and south pole, quite literally in terms of a magnet. This magnetic field surrounds it, just as there's a magnetic field around a bar magnet. Tomorrow we'll actually be mapping out magnetic fields. So this is our artist's representation of what a magnetic field might look like around the Earth. It is not something we can see, but we can see evidence of it. If you've ever seen images of the Northern Lights, and there's a video attached in here, if you want to pause this one and go open that other one and check that out, they're quite beautiful. Think about Frozen, that movie. The sky's awake, so I'm awake. That was the Northern Lights they were seeing. So basically you can get solar wind, energy from the sun can sneak in through the magnetic field, in through the north or south pole, and interact with the magnetic field and make these brilliant colors. But the magnetic field actually does protect us from a lot of harmful material coming off of the sun. So it's a very good thing that we have one. So the second part is Earth as a magnet. Explain what scientists know about the source of Earth's magnetic field. So again, pause the video, go around, have everyone share what he or she found out, and then come back to the video. Okay, hopefully everyone shared. So it's not entirely understood, but scientists think it has something to do with the circulation of molten metal within the core. So think about that. It's all iron and nickel, both of which are ferromagnetic materials. That moving stuff helps to create a magnetic field, as best we can tell. Alright, next section, effects of Earth's magnetic field. Explain why the Earth can make magnets. Please pause the video, go around the circle just like you've done before, have everyone share what they came up with. Alright, you're back. Since the Earth itself has a large magnetic field, it's capable of making ferromagnetic material, such as iron, cobalt, and nickel, into a magnet. So if those things, you can make natural magnets with them, iron, cobalt, nickel, if they're sitting in a particular direction, you can get a magnetic field from the Earth to give those a magnetic field. And we'll talk later on more about how that happens, but you may have read or skimmed that section in the textbook or talked about this last year about seafloor spreading and how the iron in the rock align in different ways based on the Earth's magnetic field. Earth's magnetic field has changed over its history. Okay, thinking about what you did yesterday. What worked? Go ahead, talk about the activity yesterday where you tried to make a compass work or make one out of the bowl, the foam piece, and the magnet. Pause the video, talk about it. So what you did, took the bowl, put some water in it, floated the piece on top, and then put the magnet on it. And you saw that that water provided less friction so that the magnet could turn. You could take the foam piece, and I asked you guys to try this, turn the foam piece and the magnet would flip back, pointing the other way toward geographic north. Now here's the tricky part. Why does it work? The Earth itself is like a magnet. The magnetic north, here's a confusing thing. If you think about the Earth as a magnet, that's really the South Pole. I know it's weird. The North Pole geographically is really the South Pole of the Earth magnet, the south end of the magnet. So the part of your magnet yesterday that was in the bowl was the north end of the magnet. The north end of the magnet was pointing north toward the south end of the Earth magnet. So that's really, I would suggest in your drawing that you did yesterday, make note of this, that really, so this is the back of the classroom where the American flag is. That is pointing, if you take your finger and point at the American flag right now, you're pointing toward the south end of the Earth magnet, which we know is toward geographic north, but it's the south end of the magnet. That's going to be helpful in the activity you do today. Just a side note, using what you learned, some insects and birds have tiny particles of iron in parts of their bodies that are connected to nerves in their brains. What could the function of this system be? So pause the video, talk about what did you think? Okay, so a lot of some animals use this to help them migrate. There's a video in the classroom that you can use to help you check that out. So what you're doing next, oh, sorry, we need to get some definitions down. So in your sheet, you need to pause the video, go get from the substitute teacher a sheet, Magnetism Lesson 2. We're on to new stuff here. You want to get one of those and then come back to the video. Alright, just like we've done before, we've got this word, magnetic pole, and we've got some definitions and notes to get down. So same thing, I'm going to give you two definitions, you take your pick. Here's the complicated version. Magnetic pole, each of the 2 points or regions of a magnet from which the lines of magnetic force are directed, or the place where a magnetic field is the strongest. So some parts of the magnet, when you've played with magnets before, you've seen there are some parts that are stronger than others. So make sure you get these definitions down, pause the video if you need to. Okay, on to magnetism activity 2. You can go ahead and get back with your seat partners, hopefully they're done too. Your question is, how do magnetic poles interact? What you're going to be doing is you've got a bowl with the same materials. You've got that tiny little magnet, a foam piece, and a compass. You're going to, and there are some other magnets in there as well. You need to figure out a way to tell where the north and south poles of all these magnets are. None of them are labeled. None of them have an N or an S on them. You need to try to show, all they have, there's some bars that have a little white dot on them. You need to figure out where north and south pole is, and with your illustrations, try to explain what's going on here. So you're going to play a bit here, and on the sheet, you want to jot down your thoughts, draw some pictures. If you have time, then you can go ahead and get onto your homework, which is on the back side of the sheet that you got from the substitute teacher. Go ahead and do that.